What does a 130-year-old know about the future? What does a bicycle mechanic know about cutting-edge technology? What does India's first iron plough have to do with renewable energy? As it turns out, a lot. Because creating solutions isn't what we know. It's about what we're prepared to learn together. Machinery and technology may have their limits, but dreams and the will to learn are beyond limits.
So the machine that we need to compress the air from one set point to another set point, we need a compressor. So that is the application. So there are various type of compressors in this segment, and that is based on the flow of the air that you need and the pressure of the air that you need. So if you see the reciprocating compressor, this is a piston type compressor. You must have seen the compressor on the tank here. You know, those piston type B type cylinder compressors. So where we need the high pressure but very low flow, the piston type of compressor is very suitable for the industries. It can go up to 300 bar. So high pressure is the main advantage of having the piston compressor. Then there is a centrifugal compressor. It is just like a pump, impeller. Have you seen the impeller in the pump? So it is the same phenomena, but it in a reverse manner. It pushes the air to the out, so that pressure can go up. So that application where we need a extra amount of flow, like extravagant, uh, beyond 2000 3000 cfm, there we use the centrifugal type of compressor. Then there is electric screw compressor. When I say electric screw compressor, basically it is driven by the electric motor. So if the compressor is driven by the electric motor, three-phase induction electric motor, it is called as electric screw compressor. Then it's water well compressor. So it's driven by the diesel engine, and the application is written in the name itself. It's water well. So for the borewell application or the drilling application in the mining, we use these kind of compressors. And the last part is the diesel portable compressors. So these compressors are mounted on the trailer or either on the skid. These are used in mining, construction, drilling, jackhammers, or from little to complex operations. We use diesel portable compressor. It is driven by the Kirloskar engine. So since you are already acquainted with the Kirloskar engines, it is very easy to operate as well. So I will tell you in a detail what kind of internal parts are there for the portable compressor. So this is the main, this and electric screw compressor, this one and the diesel portable. So these are the two ranges which are quite frequently required in Zambian market. Like if you go to mining, then mostly the diesel portable is the range of compressor that is frequently required. It is operated by the diesel engine and the pressure range is between 8 to 10 bar. So I will more focused on electric screw and the diesel portable going forward in the presentation, rather than focusing on the other product. These are the more oriented to the big industrial companies, which is not that much required in Zambian market. But the diesel portable and electric screw are the important one. Okay, so as I explained earlier, the product range, how we decide which compressor is suitable for which application. I will just explain in a nutshell, not in a detail, but just to know, like there are four type of compressor. So which compressor we can quote to the customer, which compressor, how can we know that which compressor does he need, whether it's a screw, whether it's a piston, whether it's a centrifugal, oil free, oil lubricated, what kind of application. So there is a ranges of the pressure and the cfm. Cfm is nothing but the amount of air that goes through the compressor. So bigger the flow, bigger the size of the compressor basically. So that decides the flow of the compressor. Like the one that you have here in garage or the one that you get it on the tank, the flow is very less, and that's why the size of the compressor is also very compact. Bigger the flow, bigger the size of the compressor, bigger the kilowatt on the motor. If the flow is around 32,000 cfm, let's say, and the pressure is also very medium, like 7 to 13 bar, that is mostly required for the industrial application. In that case, we can give the option of electric screw compressor. So basically these are driven by the electric motor. If the flow is between 155 to 1200 cfm, but again the pressure is kindly higher, 7 to 23 kg, then we can quote the portable compressors or the engine driven compressors. Centrifugal is on the very high flow, like it start itself from 1600 cfm. So it is for the high flow, like paper industries, pharmaceutical, electricity generation, power plants, where we need very high flow. The centrifugal is more suitable on those applications. And the reciprocating is more suitable for the high pressure. So if the pressure is from 1 to like around up to 400 bar, we can use the pressure reciprocating compressors. Now coming back to the basics of compressed air, we all know compressor sucks the atmospheric air, which contain around 78% of nitrogen and 21% of oxygen. So normal air here, atmospheric air, is having that percentage of nitrogen and oxygen. That's the air around us, which compressor sucks and takes to the another pressure. So it's a pictorial depiction of what exactly compression does means. So if suppose this is the air, artificial air, and if somebody pushes that air to the small area, now they, if you see here, the area is bigger, that's why the pressure is not generating. But if to create the pressure, obviously the area of the restrictions has to go narrower. So if you see here, the person is pushing the air, suppose on this restricted area, obviously the pressure will be higher on this point, right, instead of compared to this point. So if it is a 0 here, it will become 2 bar here. So this is general, it's nothing but the compressed air. It is nothing but the process of compressing the air. So instead of this equipment, we use the compressor, the electric motor driven or the diesel engine driven. So that's the compressor. Why it is used? So there are various advantages of using the compressed air. Like it is very easy for storing or transmitting the energy. It is relatively very safe. Compressed air is more flexible. It saves time and increase production. Compressed air is just cooling, cleaning, and movement. Compressor is nothing but the mechanical device that increases the pressure of a gas by reducing its volume. So reducing the volume is very important. Otherwise, we can't able to increase the pressure. Pressure and the volume are inversely proportional. If you reduce the volume, the pressure will go up. So compressor is a mechanical device that increases the pressure of a gas by reducing its volume. Air compressor is a device that converts power into a potential energy stored in a pressurizer. That means it's the same, like it uses the power from the electric motor and convert into the pressure of the air. And what we compress, generally natural gas, oxygen, nitrogen, biogas, or any other important industrial gases that is used for the application. So that is the application of the. So this is the piston compressor. If you see here, it's a typical piston compressor used in most of the compressors. So this is a piston going from bottom position to top position, and the air, if you see, this is the suction air coming from one pipe. When the piston goes from top to bottom, it sucks the air, and when the piston goes from bottom to top, it pushes the air but into the discharge port, and that's why the pressure goes up on that air. So it's a simple phenomena, same like engine or any pump or anything. Same in the compressor as well. It just sucks the air and pushes to the different pressure range in the cylinder. The type of compressor that I told you earlier, so this is a piston type compressor because the piston is there and it compresses the air. When I say screw compressor, basically these screws are there. I will show you in the next slide. These are the screws. These are the screws. So what it does, it rotates on this axis, on this one. And suppose this is the inlet. This is the suction air. It comes to this loop, male and female rotor. It compresses the air and it goes to the outlet. So that's, instead of piston, it uses the screw. So that's why it's called the rotary compressors. So the screws that I was referring, these are the screw compressors. So if you see here, these are the two rotors mounted on the two different shafts, but there is a clearance between these shafts. A small clearance, like a micromillimeter clearance, is there, and that is causing the pressure to go up. So it sucks the air from one end and goes to the other end. By this point, the red, you can see the red here. That means the pressure has gone up at that point, and that's how the compression takes place. So these are the screw compressors. So all the diesel engine driven compressors and the one that we saw in mine yesterday, the Doosan or the Atlas Copco, these are having the screw compressor like this. So this is the main element. This is the heart of compressor that is called, because actual compression of the air takes place at this point. So there is a cover, then there is a engine connected to this, because the energy has to be generated. It has to be rotated by some external force. So we either use the electric motor or we use the diesel engine to drive it. So this is the electric screw compressor, the brochure that I gave you. these are the type of, like, our 160 kilowatt is nothing but the kilowatt of the electric motor that we use for the compressor. So more the kilowatt, as you can see, the more the flow of the air. So there is 31 to 61 cfm from 7 to 11 kilowatt. If you compare 75 to 90 kilowatt, the cfm or the flow of the air has gone up, but the pressure remains same, because the most of the industrial application need the pressure between 7 to 13 bar. So pressure remains same.
Compressors that you normally stop, they don't go over.
They can go up to, beyond 13 bar, but again it's depend on the application. So in this range, like screw compressor range, electric motor driven, it can go up to 13 bar, 7 to 13. If we have to go beyond 13 bar, then we have to change the type of compressor. Maybe if someone needs 25 bar or 30 bar, then for the PET bottling, for example, in the industry, for the, they need the high pressure air, where we need 40 bar. So we have to use the piston type of compressor, not the screw type.
Okay.
Yeah, because up to certain bar, the screw compressor can go. So our range is from 7 to 13 bar, and from 7 kilowatt to 160 kilowatt. But yeah, we can go if we get the inquiry or the, the question about, do you have the compressor of 40 bar? No, definitely we have. Pressure is same, because the industrial requirement of air pressure is between 7 to 13 bar. Like if we use the pneumatic tools here to tighten the bolts or tighten the nuts on the any machines, we need those drilling guns. Have you seen those guns that tightens the bolts and nuts by the air pressure? So pressure on that guns is always 8 to 9 bar, or maximum 10 bar, because we don't need more than 10 bar pressure on that guns. Jackhammer, if you use the jackhammer in the industry, we need the pressure around 8 to 10 bar. We don't need pressure beyond 10 bar, otherwise that hammer or that equipment will get broken. So there are application in the industry. These are more industrial application driven compressors. That's why the pressure doesn't change. Any compressor is having these basic systems in it. So it starts from inlet system, which sucks the air actually in the inlet. Then it's a air end system. Air end system is nothing but actual compression, where the actual compression takes place. So the screw block that I show you in the animation, that is nothing but the actual compression place. That's the air end system. Drive system, nothing but with what force it is driving. Either it's an electric motor or it's a diesel engine. So that's a drive system. Discharge system is nothing but when the compressed air at 8 bar goes out, it goes through the cooler, it cools down a little bit and then goes to the final application. So that's the discharge system. Cooling system, every compressor is having the cooling system in it, because we need to cool the oil in the compressor, we need to cool the air as well sometimes. So for that one, we need to, if it is a water cooled compressor, we need to cool the water as well. So there is a radiator and the other heat exchangers as per the compressor types available in the compressor. So that is nothing but the cooling system. Then the control system. So control system basically act as a device that controls pressure and the flow of the compressor. So not always we need, because there has to be unloading of the compressor, otherwise the pressure will go up, 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 up. So as a safety measure, the control system act as a uh, medium where we can have the different controlling in the system. Like if the pressure, if the compressor is acting at 8 bar, if we set in the controller that 8 bar is the pressure, that's unloading pressure. When the air reaches to 8 bar, it will unload through solenoid valve. It gives the signal, it will unload the compressor. If the temperature goes up, oil temperature goes beyond 120 degree, then we have the setting in the controller, the compressor should trip. If it is 110 degree, there should be alarm in the system. So there are the programs in the controller. According to that, the control system acts. And the electrical system is nothing but the various switches, contactors, then the star delta starter or any starter, control system, wiring, that is a part of complete electrical system in the compressor. So these are the main 6 systems in the any air compressor. Maybe it's a diesel engine, even the small compressor, electrical motor driven, high pressure compressor, piston compressor. You take any compressor, it has these 6 basic systems. So this is a schematic of electric motor driven compressor. This is the electric motor. You can see the filter here, that's nothing but the air suction filter. This is the actual compression air end. This is a screw type of compressor. So actual compression takes place here. This is the coupling between the compressor side and the motor side. This is the tank. So this tank is air oil separator. So now this is basically this is a oil lubricated compressor. We need oil in the system. We need oil because we need to cool down the temperature, and we need to have the oil for the lubrication purpose. So oil is for the two application. One is to reduce down the temperature in the system, and other is for the lubrication in the system. So that's why we need the compressor oil in the system. So this oil gets separated here in this tank, and only the air goes to the your radiator, and it goes to the final application. So we don't want air to be there with the oil to be there with the air. We just want the compressed air. So oil gets separated in this tank. That's the application of the tank air oil separator. So here the oil gets separated from the tank. This oil come back again to this air end, and again circulate with the coming air. So that's a repetitive cycle goes on operating. So to start with, this is the suction filter. For example, it is sucking the air from here. The air is coming, the atmospheric air is coming from here to the suction wall. It is going here. Actual compression takes place, and the oil is also here. So now it's only air is coming this side, but from here, air plus oil is going. So if you see this, then the mixture of air plus oil is going to the tank. So this pipe is having the mixture of air and oil. So in this tank, there is a separator inside the tank, which separate the air from the oil. So oil gets accumulated at the bottom of the tank, and the air goes out from this pipe. Only the air. So this air is goes to the your cooling cooler, and finally it goes to your final application. And there is an oil filter here, which oil is also now the separated oil is also going to the cooler. It cools down into the radiator, and it goes back to the oil filter. It gets filtered here, and from there on it goes back again to the compressor. So that's how the oil circuit and the air circuit works in any machine. Maybe it's instead of motor, maybe it's a diesel engine, but the operation remains same, or the philosophy remains same. Now this is another wall here. That's a part of control system that I explained earlier. So basically this is nothing but the outlet air. This is your air. So when the air plus oil is going into this tank, the oil gets separated there. From there on, oil goes to the cooler, but the air which is got separated from the oil is coming from this pipe, and it goes to your final application. So this is the air line, and these are all oil lines. The orange line that you see is yellow. This is it's oil line. This is the oil cooling. So this is the oil cooling in the radiator, and this is the way back to the filter. From filter, it again goes back to the air end, and that's how the repetitive cycles goes on. It every time it atmospheric air comes from this one, it compresses here. From there on, oil plus air goes to the tank. It separates here. From there, the air goes to your application. Oil goes to the cooler. It cools down, comes to the filter, and again comes to the air end. So that's how the cycle works. And this is the coupling number 2, where the electric motor is connected to the shaft on the compressor. So it actually gives the energy to rotate and compress the air. And the number 4 is this is nothing but the air filter. Have you seen the gears, the helical gears? When the gears engage in each other, then the teeth of one goes to the another crest of another gear when it rotates. So it's nothing but the gears. So basically, when the gear is rotating from this side, obviously the suction will create at this side, right? Because it is sucking the air and it is pulling to the other side. So it's the same phenomena. When it's rotating like this one, the suction part will create at the top side. It will suck the air from that air filter, and at the bottom of this air end, the high pressure air will go to the discharge side. And the oil connections are all over this place. So there is an oil connection which put the oil here, and it mixes with the air, and it goes to the discharge. So for the smaller range, we also have the tank, storage tank. But if we go from 15 kilowatt onwards, in terms of the kilowatt or the size of the compressor, then we don't have the storage tank. Then in that case, what we do, we quote compressors, we give compressors, and the external tank we give it to the customer. Because obviously the size of the compressor goes up, the size of the tank is also goes up. So it is not feasible to put the compressor always on the tank. So tank is a different one, and the compressor is a different entity. So what we do, we quote, like for example 30 kilowatt, we quote the compressor as a separate entity, and suppose we need like 0.5 meter cube of tank for that compressor, we quote the tank separately, and the tank is on this place, compressor is on that place, and we connect it through the pipe. So that's such becomes. So now this is the air connection, right? So here the separation takes place. Oil got separated from the air, and only the air coming to this cooler, it gets cooled down here a little bit if required, and from there, if you see here, it's ended here. So that's where the actual your piping in the factory start. So customer can connect the pipe from this one. So our scope is only this one. So if you see this picture of the compressor, this one, so now it's not showing here, but there is a discharge port here. So that pipe is coming from that one, from the 7 point. So that pipe comes to this point, and customer connect the pipe here, and that can go to the receiver and other applications wherever required. So this is the exact place where the compression takes place. This is the screw, the male and female. The suction takes place from the top, and the outlet can go from the bottom. This is the shaft connecting to the motor by the coupling. This is the complete air end. This is the filter. This is a typical cooler that we use for the oil cooling and the air cooling. Now this is the complete assembly. Number 3 and number 1. 1, 2, 3 in fact. So this 1, 2, 3 motor is connected with the air end. What does it mean? It means this one. 1, 2 and 3. So this is the electric motor. This is the coupling in between. Coupling is nothing but like is a flexible coupling that connect the two shaft of the motor shaft and the air end shaft. So that's the coupling part, and this is the actual air end. So if you see the hole here, that's the suction, and the discharge port is here, and there are two gears there inside. So that actually compress the air. So this is the complete drive system that we call. This is the cooling system, radiator, fan driven. So there is a fan behind the cooler, and it cools down the air and oil. This is the discharge system. So tank that I mentioned, the tank over here. Number 6, this one. So this is the tank here. It's the inside items of the tank. So this is the tank. This is the inlet to the tank. So air plus oil comes here. Then there is a filter. All these parts goes inside. This is a filter here inside the tank. So when this is the inlet of the air plus oil. So when the air plus oil comes into the tank, it goes on the perimeter of the tank, and because of the gravity or the vortex reaction or the phenomena, the oil gets separated from the air because oil is thick and heavier in density. So oil gets in the bottom of the tank and the air is lighter. It goes through the filter, inside the filter, and it goes to the top. So this is the typical controller on the electric screw compressor. So this is a Mitsubishi type of controller. So if you see, there is like start, stop, reset, and the accept. If there is any alarm or tripping in the machine, we can accept it. We can see the various parameter here. There are various buttons here where we up, down, or see the parameter, go into the settings and stuff. So it's easy to. So this is the complete system. On the bigger compressor, we don't supply tank, but we supply tank as a different entity. So that air goes to the tank, that goes to the filter, that goes to dryer. If somebody needs dryer, purpose of the dryer is to get the condensate out of the air. There is a water in the air. So if they need very clean air, they don't want any water content in the air, then it has to taken it out from the dryer, and there is a filter. So that's a typical compressed air system. VFDs also we can give if someone needs star delta. We can star delta is already there, but if someone needs VFD, we can give the VFD. So these are the application of the compressors. Where it goes? It goes to chemical industry, food industry, pharma, textile, automobile, ash handling, sugar industry, cement, oil, gas, steel plant. So any industrial application where the engineering activities are there, they need compressed air. And all right. So yeah, this was the basics about the compressors. So in compressor there are two type of spares. One is the consumables and other is the critical spares. So consumables are nothing but the filters, oil filter, oil, then which changes on a frequent basis. Those are the consumables. And the critical spares are nothing but the kits, like the intake kits and the discharge kits. Those are the kits. So model to model, I will tell you what are the spares needs to keep in stock. But in South Africa, we have the huge range of inventory.
On the small compressors, normally we using the Yamaha.
Yes.
Yeah, but on big compressors, was the time when we requested Kirloskar, and because Kirloskar, the branch where the compressors are, we brought some. I know Lusaka, we have some
Yeah,
compressors there.
in Lusaka, yes.
But what we need to do is to see which models and brands can move in our market in future. then we can look at that.
Correct,
Yeah,
correct.
the only important thing right now is this time is coming now because as we are saying, we need knowledge on this thing.
Absolutely.
And it's good that we have been given heads up and just the idea on how the compressor operates. Like a question Stephen asked was a very good question where
Yeah,
people always think a compressor is supposed to have a reason, but you can have a compressor where most of these machines they are using direct from the compressor pump. Just connect the hoses. Some compressors come with different ports, maybe 6 ports, 3 ports. You connect to any port which you want, and then you can drive your machine.
yeah. It's not the first time that Saru is dealing with the compressor. It's in the past we have dealt it, but the thing is, it was not the focused kind of business. To be frank, it was on and off. Once in a while somebody was coming here, and then so that connect was not there. But now I'm being there in South Africa and coming frequently here, and it's a focus market for us as well. Because if Atlas Copco is doing this kind of business, why not us?